Welcome to the DooDoo Divas Smells Like Money podcast. I'm your host, Suzanne Chin Taylor, CEO and founder of Creative Raven, the firm that helps wastewater industry contractors and manufacturers unlock the power of digital marketing, AI, and PR to boost sales and opportunities. Whether it's through our online marketing and lead generation programs or providing a fully outsourced marketing department, we are passionate about helping businesses in the wastewater and civil infrastructure sectors not just survive, but thrive in today's digital world. Each episode, I'll be bringing you expert tips and strategies to help you grow and succeed. Let's dive in. Well, hello, everybody, and welcome to this week's episode of the DooDoo Divas Smells Like Money podcast. Today marks the beginning of what I believe is going to be an incredibly interesting three-part series with Mr. Jay Egg, who is the president and founder of Egg Geo. So we're going to talk about some interesting sources of energy and how this is going to impact wastewater utilities, water utilities, community at large, industrial pretreatment, wastewater, and a whole host of other things that you may have never even thought about as it surrounds this particular alternative energy source. And so with that, welcome to the show, Jay.
Well, thank you for having me, Suzanne. I've long admired this podcast and am honored to be a part of it today.
Well, thank you so much. I've been wanting to bring you on for quite a while because I think what you are doing at, Egg Geo is just, some people may think, oh, wow, it feels like science fiction, but there's more and more things that are coming to the forefront in the realm of alternative energy, but how it ties into our industry and what you're doing is really, really fascinating. And so for this first part in our series, we decided that we were going to talk about how wastewater utilities, primarily wastewater treatment plants or water treatment plants, can effectively harness the energy that is just sitting there naturally, that's occurring from its process, because let's face it, it's coming in, it naturally has a lot of heat to it. And I'm going to let you get into the dynamics without talking too much over the head, but that how what we already have that we have to deal with anyway at a treatment plant could really be harvested. Some other byproducts could be harvested from what we're already doing to create revenue centers, or maybe, I don't want to say energy that could be sold to the grid, or other things that can be done with that naturally occurring energy to create, I would say, you mentioned a source for like heating and cooling of surrounding communities from what's going on at the wastewater treatment plant. And so that in of itself really intrigued me. So, okay, so how can a wastewater treatment plant actually help power a community? So I'm going to be quiet now, and I'm going to let you take us on the journey of how this all works.
Thank you, Suzanne. Okay. The problem is that we've been working with for many years now, decades, is wastewater. We understand that wastewater utilities manage a massive constant temperature resource that is often just treated as waste. And that's a fact that we all understand. So with municipal wastewater systems, their constant discharge from buildings and coming into the wastewater treatment plant nationally is 55 to 70 degrees Fahrenheit. Even during the sub-zero freezing days of winter in Minnesota, in New York, anywhere. And the interesting thing is, the same thing is true in Florida or Texas, where it may be well over 100 degrees in the desert Southwest, or easily in the mid to upper 90s in Florida. All of those plants are receiving still, and you think about it in the cooling side of things, or it's cooler, 55 to 70 degree flow. And that is a perfect and stable renewable energy source for the entire community. Now, it's important to understand, and you just tell me if I'm getting ahead, but the angle is a utility's largest liability can be turned into their largest monetary asset by doing this. What we have been doing is operating our in-ground utilities in silos. You have the electricity being distributed underground, you have the drinking water being distributed, the wastewater being uh, dispersed of to wastewater treatment plants, and the list goes on. There's also groundwater pumping that goes on through all these buildings. And that water is all part of an energy exchange, what we call the water energy nexus of things. And that's a term that was adopted by the DOE some years ago. Everything, if we start using it as a symbiotic community of utilities, can be used to benefit one another. And I'll give you just a snapshot if you'd like.
Yes, absolutely. Because what's, running through my mind is okay, great. I understand the warm temperature. I understand the water coming in. It's there. But how do you propose that you harvest the energy? I'm sure that is going through everybody's mind.
Yes. Let's talk about it at the very basis of the world's most efficient heating and cooling system. You go on the DOE site or any energy site, and you will find that the most efficient heating and cooling system available to man right now today is a geothermal heat pump. Now, that's often been treated as, yeah, but the heat pump costs this much, and then you've got to do the groundwork to get to the heat under the ground, and that usually costs another third or 100% or some odd uh, penalty to put in the ground exchange system to operate the heat pump. Because a geothermal heat pump works based on the temperature of the low temperature, the average temperature of the Earth, 6 feet and below, which is typically the median temperature of any region of the country for all 4 seasons. For example, in Minnesota, that's about 48 degrees. In New York, it's about 55 degrees. In Miami, it's about 77 degrees. But this is the average temperature. So when you think about that, an air source heat pump, if you understand that they have that outside condenser that extracts heat from the outside air to heat your home in the winter and rejects heat to the outside air to cool your home in the summer, this is why a geothermal heat pump is most effective, because when it's 0 degrees outside in the winter, it's working with 50 or 60 degrees if it's a geothermal heat pump. So it's mind-bogglingly efficient. Mind-bogglingly. It isn't even comparable to anything else. There's nothing else made that does it. The same thing with cooling. When it's 100 degrees outside in the summer, it's still at the most in the 70s. And so it's a better heat sink. We put our heat back in the ground in the summertime. So now that we understand how a geothermal heat pump works and why it's more expensive, if you're ready, I'll share, as Paul Harvey used to say, the rest of the story.
Please do.
All right. So in 2013, um, I had just finished writing my second book under commission for McGraw-Hill, a graduate level textbook on modern geothermal HVAC systems. And I didn't expect this, but one of the first to call, I got calls from all over the world to ask me to consult on these things. Meanwhile, I was running a busy engineering and construction firm based in Florida, and I get a call from the New York City Council, and they said, "Can you tell us how we can use geothermal technology to cool at least 900, to heat at least 900,000 of our 1.1 million buildings in Manhattan by 2050. And I said, that's a great question. I have an answer, but it's going to take me some time to get my head around your problem. And so they flew me up there and I did a presentation on site. And that began my journey in New York, which has been a marvelous journey. But I explained to them that in order to do this, and they already knew because they had already commissioned several writings on geothermal, and they knew it was the answer for New York. They needed to decarbonize, and that was the best way to do it. But all they knew is for about every ton of heating and cooling, they needed to put one 500-foot borehole in the ground, 4 inches in diameter. And if you total it up, it's about a bajillion boreholes in Manhattan. So they'd be making Swiss cheese out of the island. And it's all granite, which isn't a problem. It's just ridiculously redundant when there's a better answer. So that's what they were really asking me, what they can do. And so I explained a concept in 2013 called a geothermal energy network, much like a natural gas distribution line that runs around to 65 million buildings in America right now in 2.5 million miles of pipe. Those were all installed during the 50s and 60s in our built environment. They put them in after our buildings were built. I said, you got to do that in New York too. And they said, okay, what's the advantage? I said, you eliminate the need for massive boreholes. You can use the wastewater treatment plants. You can use the dewatering underground buildings. You can use the subway system. You can use the East River and the Hudson River. All these are heat sources and heat sinks. But we would perform an analysis and do a good study on what works best. And they said, what's the lowest hanging fruit to do this? And I said, wastewater. It's already there. You have 1 billion gallons coming down from northern New York through a massive aqueduct system that comes to 3 reservoirs in New York City. You use 1 billion gallons of drinking water every day for New York City. And you also treat 1 billion gallons of wastewater every day.
Right.
So, what are you doing with that wastewater? And they said, well, we send it through our wastewater treatment plants, then we dump it into the East River, cleaned to EPA specs, into the East River and into the Hudson. And I said, oh, great. You can use that as a heat source and a heat sink all year round, and it'll do roughly 25% of your entire building load in New York City. They said, tell me more. I said, you can do this, that, and the other, but I can go on and on. I created a great cartoon, which I'll share with you. It was really done for a 10-year-old, but we're dealing with legislators. You needed to do a
Well,
10-year-old.
no, okay, no comment. Don't want to tick anybody off here.
So that's I want to say that covers the wastewater angle in the overarching way. There's much more to it because we do it at the building level too, and that's really cool. And we've gotten great contracts to do them for certain high rises in the city in an isolated fashion, and that's what's proving it out.
So, getting back to the wastewater treatment plant, what kind of technology is needed to harvest that heat that's coming from that source, as you mentioned, to harvest it and then send it out to the grid so then it could be used for the buildings? So now you alluded to, you called it thermal energy networks or TENS.
Yes.
So it's being a visual person. And I think many people may be listening in today or are thinking to themselves, okay, so I understand that you can get the heat, but how
Yes.
get the heat?
Imagine this, if you will. A network of pipes similar to the wastewater piping system or the drinking water piping system in any street in any town USA. You know they're under the right of way because you see the fire hydrants and you know all the houses and buildings are connected to them. Same thing. Keep that visual. The thermal energy network is an identical pipeline, one pipe, and to each building that needs to be tapped into it, it has two pipes. Now, this is a hydronic anomaly that not many people understand unless you're a mechanical engineer. But what is called is a twin T. One T pulls water from this big pipeline that's moving a tremendous amount of water, maybe 20,000 gallons, maybe. It just depends on the branch it's running through. And it's a bunch of water that moves through according to controls to make sure it maintains a certain temperature. And our bandwidth is about 40 to 80 degrees. So we keep that water in that loop at about 40 to 80 degrees year round. The building then taps into that and pulls as much cooling, what we call it ambient temperature water for the heat pumps and central energy cooling and heating systems as they need to. And then they put what's the rejected, which in the summertime is warmer fluid, back into it. And all this is moving down. And so it's pulling cooler water out and it's dumping warmer water in and it's getting diluted by a much larger, it's like a river there. So it's essentially like a natural gas network that you only tap from because you burn it and it's done. It's one way. But in geothermal, it's a renewable system. So you put back what you take. All we're using is the BTUs. Now, in the wintertime, we've used a lot of BTUs. And where are we going to get the new BTUs from? That's the wastewater energy plant. Because by the time we go to the wastewater energy plant transfer system, the water is, say, 45 degrees and it needs more BTUs. So we send it through exchangers, a big bank of exchangers in a wastewater treatment plant energy exchange system for TENS. And they pick up all that heat and they come in at 45 and go out at 70 and they keep the loop going. And this is, as you can imagine, there's a lot more to the plumbing than I'm telling you,
Right.
but it's not just science fiction. Since 2007, a similar system was installed in the city of Toronto in Ontario, Canada. Let me explain real quick just to tell you that we have a similar opportunity that they took, but it was for cooling only. So Ontario pulls all their drinking water from, or I mean, Toronto pulls all their drinking water from Lake Ontario. And they have three huge pickup lines that come from several kilometers out and several kilometers deep in Ontario, or at least a couple of kilometers deep in the Lake Ontario. So this water comes into a water treatment plant on the shore. A government agency, which was with the Ministry of Energy, commissioned a study and eventually installed the drinking water energy transfer system for Toronto. This is a big building full of exchangers that grab all the cool water that comes into drinking water. The first they treat it to drinking water standards, then they run it through these exchangers, and that's where Toronto gets all of the cooling water that they need to cool all of downtown all
Wow.
summer long. And so they've only got one side of the magic. We have two sides of it. We do cooling and heating because we're coming from something that's all just like they use a drinking water. And by the way, we can do it on the drinking water side too. We can get it coming and going. So the point is, we're just doing that on the wastewater rejection, the treated wastewater rejection, or what we call effluent at the wastewater treatment plants. So they already do that. They have a massive Toronto chilled water system that's run from the N-Wave chilled water exchange system on the shore. And by the way, that's 40 degrees year round. The water comes in from Lake Ontario, so it's already to chilled water standards. They don't even have to run chillers.
Wow.
So the COP is out of this world. beyond anything else out there. We can do that in both heating and cooling, except the difference is we do have to run active heating and active cooling
Hmm.
and it's still it meets the geothermal standards internationally. So it's the most superior heating and cooling system in the world today.
So you had mentioned, when we were offline about this, that this could also become a revenue center for a wastewater treatment plant, or at least something that could offset their own usage, because we all know in a wastewater treatment plant, one of the biggest energy users is in their aeration tanks and in
Yes,
their pumps and their blowers.
yes,
Can a system like this be, or can they divert some of that energy that they're harvesting using this geothermal technology to actually operate the plant? And then whatever's left over, basically, well, what do we say? Charity begins at home.
yeah.
So that they take care of themselves first. And then the excess they can maybe perhaps sell to the grid or push out to the communities like we were just talking about. Is
Yes.
that a possibility?
Yes, and let me explain. One of our strategic partners in the city, and we have these strategic partners, which are electrical companies all over the country. We're working with PG&E, Southern Company, Con Ed. So I'm just going to mention what we're doing with Con Ed because it's publicly available. And so what else is publicly available is information on the Penn South community in Chelsea in downtown Manhattan. The Penn South Co-op is 22 no, 15 22-story buildings covering apartment buildings covering 5 blocks in that area. And it also includes they have on-site many commercial buildings. So they have a central energy plant right now that uses $5 million a year of natural gas. Okay. For heating. And then they have electrical consumption from Con Ed for their chillers. We've already proven through a multi-year study that is peer-reviewed that that $5 million will turn into, after they go to the system we've designed for geothermal, just for those 5 blocks, go to 1.2 million. So the value of that is absolutely clear. It's 5 million a year versus 1.2 million a year. Now, here's the really cool thing. Companies that want to own this resource, the geothermal loops, will pay top dollar to buy that resource and manage it for them so they don't have to pay the nearly $1 billion it will cost. This is a much bigger than Pinza,
Right.
but it's about $250 million just for the infrastructure for those particular buildings. They're willing to fund that, and they're going to recoup their money by charging them $3 million a year to pay for everything. So they're an energy company that will buy and pay for everything. So there's no cost to the cooperators and they will work with Con Ed and everybody else. This is a complex deal, but they'll pay for everything and then they'll sell the energy back to them for $3 million. They're automatically from day one at a $2 million net savings for the co-op. And they make their money back in spades over 20 years. So it's a really cool deal. And then they own a permanent asset. Essentially, it's an energy plant that never runs out, the geothermal system. That's what a wastewater effluent plant would become, an energy plant that always brings dividends, and you only have to pay for the upgrade once.
Wow. Well, Jay, yeah, this is mind blowing. This is mind
Yeah, it is.
going to make a lot
It's
of
next
people think
level,
about,
right?
wow, okay, yeah, maybe we should look and see if this is feasible for us. And they might need the help of someone like you to guide them through this, because you put together many of these programs successfully for these entities. And so for those who are as intrigued as I am, I don't own a wastewater treatment plant, but it's just, to me, this is fascinating of what this could do for communities, because we're all looking for alternative energy sources.
Hmm.
Not to get political, but we all know, there's a finite number of the natural resources. So we need to be looking at ways that long range, we don't have to worry about that. What we can become sustainable. And if we can do it for less money, and yet all those companies, it's almost like you're replacing one revenue source with another, and everybody wins.
Because now they don't have to pay for a consumable. Natural gas is it's still necessary. We need it for processes, for
Right.
certain things that really need the hot. But and CHPs, they're peaker energy plants, they need it for certain things. But for the individual buildings, it isn't needed anymore. It's only used strategically where it's needed, and everybody wins because even we're a bipartisan technology. The Trump administration is as favorable for this as the Biden administration was.
Interesting.
Thank goodness.
Interesting.
They've kept all the benefits from the IRA. They will that's another thing. They'll get paid for implementing this. 30% of the cost will be paid by the Fed. They have $1 trillion bucket for this, for
Wow.
paying for these nationwide. It's
Wow.
huge.
So, Jay, for anybody listening who would like to explore the potential of this further, how can they get in touch with you and learn more about what your company does and how they can, get started implementing something like this for themselves?
Well, if you can spell eggeo.com, don't be confused. It's three G's in a row. Try to find that anywhere else. EGGEO.com, or you can email me. Mine is easy. It's my first name and my last initial, JE at eggeo.com.
Great. Well, Jay, thank you so much for sharing this with us. And I'm looking forward to the next segment in our conversation as we continue to talk about the potential of geothermal energy for our industry. So thank you again. This has
Thank
been
you.
fascinating. And for those of you tuning in, hope you got something out of this. I know my wheels are turning in my head. Hope yours are too. And so until next time, keep it flowing. Thanks for tuning in to today's episode. If you're ready to take your marketing to the next level and start increasing sales and opportunities for your business, reach out to us at Creative Raven. We're here to help you thrive in the digital landscape. Visit creativeraven.com or click the link in the show notes below to schedule a call and learn how we can support your growth. If you enjoyed the insights on today's episode, be sure to hit subscribe so you'll never miss an update. Until next time, keep growing and keep it flowing.